Hello, this is Miss Moore, and today during chemistry we're going to start a discussion on the mole. Specifically today we're going to discuss converting from moles to number of atoms or molecules. Today's essential question: how do you convert from moles to number of molecules? Remember to answer the essential question as part of your summary. Also, for today's lecture you need to have a calculator, preferably a scientific calculator, handy. Right, so now before we talk about calculations, let's talk a little bit about what is a mole. So, atoms are really small, like really, really small. You guys already know that. Which means that a really small sample of elements or atoms can contain a huge number of individual atoms. So in science, we actually use really big and really small numbers. The mole is a unit used to express an amount of a substance. Okay, so a number. For example, a dozen. A dozen is an amount unit. What does a dozen mean? A dozen means 12. A mole is similar to that. It's an actual amount. We'll get to the amount in a minute. And then for history's sake, the mole is the number of atoms in exactly 12 grams of carbon. That is where the number relating to a mole came from. The mole is a counting unit. Again, it tells you how many. So the mole is a counting unit used for measuring the amount of a substance. The number of particles in a mole is called Avogadros Constant or Avogadros number. And Avogadros number is 6.022 times 10 to the 23rd. And normally, because we're in chemistry, we'll be talking about 6.022 times 10 to the 23rd atoms or molecules. Just like when we're talking about a dozen, we're usually talking about like eggs or donuts or something. But the truth is, you could have a dozen of anything, right? I could have a dozen students, a dozen shoes, whatever. So the truth is, I could have 1 mole of anything, not just 1 mole or 6.022 times 10 to the 23rd atoms or molecules, but 6.022 times 10 to the 23rd students, that would be a lot, or shoes or whatever. Okay, so we have this thing called an equality. A true statement is that 1 mole equals 6.022 times 10 to the 23rd atoms. Okay? All right, and finally, how do we convert from moles to number of atoms or molecules? Again, we'll be using the equality we just discussed, which is 1 mole equals 6.022 times 10 to the 23rd atoms or molecules. You will likely memorize this equality, but if you look on your unit conversion table on the bottom, you will see that it's written on right on your table. All right, so let's do an example. We're going to look at how many moles of NaCl, or sodium chloride, are there in 5.92 times 10 to the 12th atoms. So the first step is we want to rewrite this as a math problem. Okay, so the first thing we want to do is rewrite the problem as a math problem. And to do that, we need to know what we know and what we're trying to find out, so our x. So first of all, what we know is that we have 5.92 times 10 to the 12th, and I wrote atoms here, which is incorrect because NaCl is a molecule. A molecule is a group of atoms, and an atom would be like just the Na. All right, so my known is 5.92 times 10 to the 12th molecules. And what am I trying to find out? My question is, how many moles do I have? So I'm going to have equals x moles of NaCl. Okay, so there's our math problem. Okay, the next step is we're going to write a grid, some people call it a T-chart, and write the given or the known over 1. So we'll write this grid here. Here's our grid. And our given or our known is still this. So I'm going to have 5.92 times 10 to the 12th molecules. I'm going to abbreviate molecules as molic over 1. So I've written the grid. I wrote our given over 1, which is the second step. 3. Write the equality or the conversion factor that relates the units given in the problem. So the units we have in our problem are molecule and mole. And I just gave you the equality, which is 1 mole of something equals 6.022 times 10 to the 23rd molecules. Okay, and we can see again that mole, we have mole there, and we have molecules and molecules. So that is the conversion factor or the equality we're going to use for this particular problem. Actually, for all the problems today. Step 4, we're going to put the conversion factor, so this thing here, in the grid. So up here, so that all the units cancel out. That is super, super important. A step you do not want to skip when setting up these problems is you always want to write the units in your grid. So for example, my known was 5.92 times 10 to the 12th molecules. So looking down at our equality, since I have molecules on the top of the grid, I'm going to put molecules down at the bottom, 6.022 times 10 to the 23rd molecules. Okay, so this number went here. The other one then, whatever's left over, is going to go on the top. 1 mole is going to go on the top. Now we'll note that molecules crosses out, and we're left with the unit mole, which is what we wanted in the original question. Okay? All right, and the last step is now to just solve for this. To do that, we multiply across the top. So we're going to take 5.92 times 10 to the 12th times 1 mole, which is pretty easy. That ends up being 5.92 times 10 to the 12th times 1 mole means mole, over, multiply across the bottom, which is 1 times 6.022 times 10 to the 23rd. We'll end up with 6.022 times 10 to the 23rd. And divide. And when I put that in my calculator, I got 9.83062156 times 10 to the negative 12th. And I'm out of room, but we need to put in our units, molecules. Please double check and make sure I got that right. And we'll just keep 2 digits after the decimal. So our final answer is 9.83 times 10 to the negative 12th. I'm out of room. Let's get rid of that. Molecules. Okay. So that is how you do conversions, unit conversions between molecules and moles. All right, a few hints. Always, always, always write the units and the atoms. I call that a stupid mistake blocker. It helps you to set the problems up correctly, so it's really important. Go through all the steps. Take the time to set the whole problem up. You're more likely to get the right answer. Work carefully and neatly. Do the calculations on the calculator twice. Don't set up the whole problem twice. Just punch the numbers in your calculator twice to make sure you didn't make a mistake. And at the end, check your answer with the question, does the answer make sense? Okay, let's try a few practice problems. What I would really like you to do is hit pause and try to do number 1. Hit play, see how you did. If you did it right, awesome. If you did it wrong, figure out what you're doing wrong. And then hit pause again, try to do number 2. I would like you to be able to come into class knowing if you know this or not. All right, so hit pause at this moment, try number 1. All right, so the first step is to turn this into a math problem. And what I know is that I have 2.9 moles of KF, and what I'm trying to find out is how many molecules are that. So as a math problem, I'm going to have 2.9 mole KF equals X molecules of KF. Okay. Second step is to write the grid and put our known in the grid, which is 2.9 mole Kf over 1. All right. Third step is to find our equality that relates to units in the problem. And today we have moles and molecules. So I'm going to be using the equality 1 mole equals 6.022 times 10 to the 23rd molecules. Okay. And now this thing needs to go in up here so the units cancel out. So let's look what unit we have at the top. We have mole. So at the bottom, we're going to put the 1 mole, which means we've used this one. So that means the molecule 1 goes on top. And now, let's double check. Did we set this up right? We cross out that mole and that mole. We're left with molecules, which is what we wanted to find in the problem. So now we multiply across the top and across the bottom and then divide. So let's see, 2.9 times 6.022 times 10 to the 23rd. And that gave me 1.74638 times 10 to the 24th molecules Kf. If I keep two numbers after the decimal, I'm going to end up with 1.75 because this 6 is 5 or bigger, which makes the 4 round up, times 10 to the 24th molecules of Kf. All right, cool. Why don't you hit pause and try number 2. So once again, we start by writing our math problem. This time we know how many atoms of neon we have. What we're trying to find out is how many moles that is. So my math problem will be 4.98 times 10 to the 22nd atoms of neon equals X mole of neon. Let's set up our grid and write our known over 1. So we're going to have 4.98 times 10 to the 22nd atoms of neon over 1. Third step, our equality. Again, we have atoms and moles, so our equality is going to be 1 mole equals 6.022 times 10 to the 23rd atoms. And this needs to go in our grid, setting it up so we can cancel out units. And this time we have atoms on the top, so we're going to put atoms on the bottom. Which means the top is going to have what's left over. We used atoms, so we're going to have 1 mole at the top. Okay, let's double check. Do atoms cross out atoms? Yes, they do. So now let's multiply across the top, giving us 4.98 times 10 to the 22nd mole of neon over 6.022 times 10 to the 23rd. Divide. And in my calculator, I got 0.08296 and some more mole neon. And we'll keep 2 non-zero numbers after the decimal. So we'll keep this 0 and this 0 and the 8 and the 2, which means we're going to drop this stuff here, and since the 6 is 5 or bigger, our final answer will be 0.0823 mole neon. Okay, so this stuff isn't too bad, but it is important that you're careful and neat. Do all the steps, write your units, cancel them out, and then your only place to make mistakes is plugging in the calculator. All right, that's it for today. Have a good one.